so this question is asking us to find a length DC in a non-right angle triangle. So straight away we're thinking about sine rule, cosine rule, and if we take a moment to read the question fully, we see we've got more information given to us. Size of angle BCA, going to call X, and we know that DAC, D to A to C, so this one here, is 2/5 of this, so 2/5 of X. So if we can work X out, we then know this one, and we'll also be able to work out this one because 180 degrees in a triangle. Remembering what we're actually trying to find, we're trying to find this side here, I'm going to call it Y. So if I would knew that and I knew this, I'd be able to use the sine rule, a side and an angle opposite it, and a side and an angle opposite it. I'd be able to find my missing side. So that's the route we're going to take through the question. So we need to start off by finding angle X. To do that, we need to look at the bigger triangle, this one, ABC, where we've been given all three sides. It's not a right angle triangle, but we know all three sides, so we're going to use the cosine rule. Now, the cosine rule to find any angle would be b squared plus c squared take a squared over 2bc. That would be cos of the angle. Remembering that the angle we're trying to find, the two sides that we're going to square and add together, these have to be the sides next to it. The side opposite it is going to be a little a. So you can label them kind of whatever way you want really, but you've got to remember that in the angle you're trying to find, the side that we take away is the one that is opposite it. So putting the right values into this, we're going to find cos of x equals one of the sides next to it plus the other side next to it, take away the side opposite it, all of those squared, divided by 2 times side times side. Putting that into your calculator gives you 0.8473. What we then want to do is find out what x is, so we need to do arc cos or inverse cos of 0.87473. Do need to make sure that your calculator is in degrees mode, not radians. It hasn't kind of knocked off the setting in your bag. And we get that x is 32.08079, which is pretty accurate, but it's not my final answer, so I'm going to leave it as that for the moment. I'm actually going to leave that answer on my calculator screen and possibly refer to it in a minute. So that angle is this one here. So I'm just going to label that. It's 32.0807. And I know that this one is 2/5 of that. So angle BAC is 2/5 of 32.08079. Hence, because it's already on my calculator, whatever I've got stored, I'm just literally going to type in times by 2/5. And that gives me 12.83. Again, not quite going to the three significant figures just yet, keeping it a bit more accurate. So this one here is 12.83. Can find this one then easily by adding those two together. So adding 32.087807 and taking it away from 180, so 180 take away the answer that I've got, and I can see that this angle here is 135.09. So angle ADC equals 135.09, and that's still not quite going as accurate as I need to go in the final answer. Right, coming back now then and using the sine rule, I'm almost there. I can see that I want this side here, so I'm going to call that y over sine of the angle opposite it, so 12.83, and I know that that equals another side, 6.2, over sine of the angle opposite it. I've run out of space, but 135.09. So in order to solve that, I'm literally going to do 6.2 divided by this and then multiply it by that to get y on its own. So 6.2 divided by sine of the answer stored in my calculator multiplied by sine 12.83, press equals, gives me 1.95 and 3 zeros. Just double checking the question, 3 significant figures, so y equals 1.95.